All right. So let's start. Once again, welcome everyone to the TailorTech Data Engineering Masterclass, Understanding the Role, Tools, and Career Path. So my name is Natik Taylor, and I'm part of TailorTech team. We also have here with us Umang, who is the co-founder of TailorTech. So in today's session, we will explore what data engineering is, why it has become such an important field in the modern data ecosystem, and how data engineers build the systems that power data-driven companies. So, before we begin the technical part and move to what is data engineering is and everything, so let me first briefly introduce what is TeleTech. So, TeleTech is our initiative, which is an industry focused learning platform designed to help learners become interview ready and job ready for modern technology roles. So, our program focused on real industry tools and workflows, hands on learning with practical projects, interview preparations, and expert guidelines designed to help learners confidently crack tech interviews. So, Teletech is focused on helping learners move beyond just learning concepts and actually becoming interview ready and job ready for the technological roles. Many people learn different tools online nowadays. You can see many online courses are there, but they often struggle with comes when it comes to the applying those skills in real scenarios and during the interviews. So, what at Talatech, what our goal is to bridge that gap, which focusing on practical skills, real industry tools, and structured interview preparation, so that learners can confidently step into the technological roles. So, before we start the master session, Umang, please can you help me with the attendance link? So please, because what is there, we will be sharing a digital certificate to all of you guys. So based on the attendance only, we can share you the certificates. So meanwhile, people are filling the form and everything. So let's begin. To guide us today's session, we have an experienced industry profession with over 13 years of experience in software development and training. He has worked extensively with technologies such as Python, SQL, Apache Spark, Databricks, and big data engineering systems. So please join me in welcoming Mr. Dhyaneshwar Barber, who will be the leading this masterclass today. So over to you, Dhaneshwar.
Hey, thanks, Naitik. Hi, everyone. Good morning, good evening. I think for most of you it's late evening. Thank you so much for joining in. Uh, so, without a further delay, we will quickly start with the session. So, let me start with my introduction first. You should know your a speaker, so it's always good to know basically where to whom you are listening. So, I'm a computer professional. I graduated, post-graduated in computer science and engineering, and around 13 plus years I'm working in this industry. And most of this experience actually comes from training as well as software development. Then, if as Naitik already mentioned about my technology stack, anything and everything about data is basically my primary tech stack. The programming languages like Python, SQL, then the various databases, the relational, non-relational databases. I already worked on Apache Spark, Hadoop, and as of now, people are leveraging different capabilities from managed environments or readily available platforms to implement end-to-end data pipelines or processes for data engineering. Those platforms are like Snowflake and Databricks. I work on Databricks as well, and any some other related data engineering technologies. Uh, just to mention about my past projects, I have worked on some projects which were related to handling the stock market data. I was getting data from the stock exchange. I was responsible to build an API to accept that data and ingest data regularly on our XYZ desired sources by processing that data, and then building some other APIs to perform a backtesting. So basically, backtesting is a mechanism for testing our trading strategies over the last 10 years, 15 years. If we have executed XYZ strategy, how much profit, how much loss we would have made. So for that purpose, typically people do backtesting before deploying the strategies in the real market. So I was preparing those APIs. This is just one part of my experience which I wanted to share with you. And now let's go ahead. So, Naitik, can we please move on to next slide? So for this session today, this is the agenda which we are planning to go ahead. So we will first of all understand why the data engineering is becoming important nowadays, why it's coming as a new career for the IT professionals, even the non-tech guys. Then what are the responsibilities what data engineers will be doing in his day in and day out. Then we will also see what exactly are the terms data pipeline and data workflows, which we typically keep on listening a lot. Uh, what different phases data moves throughout its life cycle when we process it. Then different tools which are commonly used for data engineering processes. Then we have some real-time pipeline examples to discuss here with, and uh, then we'll discuss the career path for data engineers. Exactly how we can or how one can build a career for becoming a data engineer. So that's the agenda for today. Can you go to the next? Thank you. Okay, so the first pointer, importance of data engineering. Uh, like this is not a new like very new domain of the work, but why people have started talking a lot about data engineering. I just wanted to make this to you to understand quickly by a small activity. So I request you to search a small query on the browser, okay? And that search will be 60 seconds of internet, or you just write 1 minute of internet. Everyone, you just open the browser tab, and in the browser tab you just need to search uh, what happens in 1 minute over the internet, or you just write 60 seconds of internet. You will get some search results. You can move to the image section on the search results search page, and just try to read some images from there. Any images which are looking good to you, you can refer to that image and try to understand some facts, some statistics from those images. And it will be really great if you could share those facts here. I hope you understood the task. It's very simple. You just need to search
Hi,
60 seconds of
hello.
internet over the.
ఆరే ఉన్నాయి ఇక్కడ
Uh,
ఆరే పెట్టేయాలా
hey, Vishnu, can you please go on mute? You don't need to share the. Uh, Okay. You don't need to share the link of images. I want you people to read through those facts. And if you find any fact which is very interesting to know, you can put that fact in chat. Just type that fact in chat. Let's say what happens on a YouTube or what happens on the Instagram in just 1 minute of time nowadays.
विजय order for Vijay.
Thanks, Vamsi, for sharing that. Vamsi says 5.2 million, 5.2 millions views on YouTube videos. Yes. Similar to that, some interesting facts can we have. 43 years of streaming content. Users send around more than 41 million messages through WhatsApp. And these are the
Order for Vijay.
statistics per minute.
65 and one Andhra chicken with two Malabar pakoda.
I request everyone to please be on mute so that
Chicken tikka masala and three naans, one chola bhature.
Wow, Vishnu, that looks yummy. But can you please go and mute? Uh, I think you can mute him. He might not be near to. Yeah.
yeah, I just did.
Yep. Okay. Wow. Sai, 500K apps download, but from where exactly? Is it App Store or Play Store? 231 million email are sent. $453,000 sales are made on Amazon. Wow. Awesome. And like that, believe me, like that, there are more interesting facts which we can still have. What exactly happens in every 1 minute of internet? So there are big giants, big players in the market who are dealing with the data. Okay, thanks for sharing those lovely stats, guys. So, okay, now I'll take a minute to discuss this thing. Why exactly I asked you to do this, and then we'll quickly move ahead. So, like Netflix, companies like Google, Microsoft, Netflix, or Meta, on lot many such big companies in the world who are gathering the data or who are processing the data in the background. And I just wanted to get some idea what amount of data they are dealing with, at which rate the data is getting generated. So uh, it's not a very easy, it's not a very typical process to handle such data. For this, we need a good architecture. We need a good background of understanding the characteristics of the data and different platforms available in the market to process that data. So yes, the main point here was the amount of data which is getting generated every second, and how industries are processing that data. We need to understand that, right? So that's why typically we say big data, where we deal with the huge amount of data. You might have heard about three V's, the characteristics of big data: variety, velocity, and volume. So variety is different types of data. Well, velocity is at which rate the data is being generated, and volume is the amount of data. It's gigabytes and terabytes of data or petabytes of data which is getting generated, and industries need to process them to get some quick insights out of the data and run their businesses efficiently using that. Okay, so that was the first task, and that's where the data engineering come into the picture, where we will have a standard framework where we will keep on ingesting such data and keep that data processing, and businesses can leverage the insights which will come out of that data processing. Okay, next slide, please. Now, as a data engineer, what responsibilities any person will be performing in his job? First of all, the big data processing, as we talked, huge amount of data is getting involved in any business process. how efficiently we can process that data. Now, when we say process, it's also a very broader term. What exactly are the different aspects of data processing? We might discuss them in the upcoming slides. So big data processing uh, is one task. Data integration and transformation. Now, when different sources are generating the data, that data might not be in a common format. We need to transform the data. We need to uh, bring the data into common format, and then we will connect that data and put to the common location, store to the common location. Data warehouse management. Okay, as the term came here, the data warehouse, I just want to know, are you guys aware of data warehouse, the term data warehouse? Have you heard this before, or typically how it is different from the database system? What can you say about data warehouse? And please be interactive. If you have any questions, you want to ask those questions, guys, feel free to ask. Or even towards the end of the session, we might have some question answer session. So you can ask your doubts there also. But if you want to ask, you can ask me to pause, ask your questions, and we can keep it really interactive. So I want your thoughts on the term data warehouse. You may either write in a chat, or you can just unmute yourself and just talk to me about the data warehouse, how it is different than the database system, or is it same to the database system with some extension? What exactly it is? What is your understanding? Because that's a very important term when we start talking about data analytics, right?
Hey, excuse me, can I tell the difference
Yes,
between database and data warehouse?
yes, sure.
Yeah. So basically, the main purpose of the data warehouse is to process analytical data. So we can't do that in a traditional databases.
Right.
Traditional databases, if you do analytical process on a traditional databases already uh, designed to process the transactional data. That means we need high throughput and low latency. If we use the same database for the analytical processing, that may slow down the real purpose of the transactional database. That's why they come up with a different database. They named it as a data warehouse to serve the purpose of the analytical data processing.
Awesome. Uh, Thank you for sharing this. Naitik, I think some screen has come up from your end, lower right corner. I'm not able to, yeah, now it's gone. Thank you. Hey, thank you so much for your sharing your thoughts. So that's absolutely correct answer. So not all the operations we can perform on the typical operational databases. So business might have different database systems, but those systems are for running the businesses. Whatever the day-to-day basis business activities are there, to execute those activities in a computerized way, they use typically the database servers to execute or to support executing these tasks day-to-day basis. But on the other hand, they also need to run some analytics to understand their business processes, what's happening, and how can they grow? How can any company grow their sales? How can they grow their profits? What should be the marketing strategy and all? So for running such kind of analytics, they need the system, which will be the typically data warehouse system. And so in short, if I want to tell you, database system is to run the businesses, and data warehouse is to analyze the businesses. And there is one process in between, which is typically called as ETL process, the extract transform load, which converts or which gets the data from data sources, the transactional data, and keep on loading the data to the data warehouses. So that's one of the area typically we talk when we start talking about the data engineering. Yeah. Then design and development data pipelines. When we need to move the data from one source to another source, we create a structured pipelines, like a typical set of multiple steps performed one after another. So that creating such pipelines will again be the responsibility of data engineer. Workflow orchestration. So pipelines and workflow, very shortly we'll discuss these terms, but typically when it comes to execute multiple processes to deal with the data, so multiple such processes need to be scheduled for the execution. They need to be monitored, whether they are executing successfully or no. So that happens through the orchestration process, and for that also we have some standard tools available in the market. So that is also one of the core responsibility of the data engineer. Then cloud platform utilization. When we start talking about a huge amount of data processing it through some standard process, standard pipeline, it's not going to happen on the local machines. So for that, we need to leverage the cloud services. So what different clouds we have? Typically the three big cloud service providers in the world: Amazon AWS, Microsoft Azure, and Google GCP, right? So these giants are having readily available infrastructure for the people like you and me. We can subscribe to their services and we can use readily available services for implementing our data engineering pipelines. And along with that, maintaining the data quality and monitoring. Because as we mentioned, we are going to create the data for analytics. So if the data quality is not up to the mark, if data quality is not good, how the insights can be trustworthy, how the business will get that confidence that whatever the outcomes we are getting outside out of sorry whatever the outcomes we are getting out of that analytical processes, how genuine it is, right? So data has to be a very correct data. So there are different factors again which defines data quality. And so data quality and monitoring is also a responsibility of a data engineer. And lastly, develop and manage the data platforms. There will be different platforms, uh, different softwares through which we will be managing all these data processes. So to learn or to understand different functionalities and different capabilities of such platforms and use it for processing the data effectively. All these are the roles, and typically data engineer will be involved in such kind of activities. Next slide, please. Yeah. So as we came across these terms in the previous slide, so now let's try to see exactly what do we mean by data pipeline or a workflow and work orchestration. So data pipeline is a systematic movement of a data from one thing to one source to another, another source of the storage. So it can be, let's say, a typical file storage to database, or maybe from any typical relational database to the cloud storage like S3, or any typical source. Maybe as we discussed, data movement from our transactional databases to the warehouse systems. That can also happen. So here we read the data from sources, we process it, we perform some operation on the data for cleaning the data to enrich the quality of the data, and then we store it at a desired target. Typical example, if you want to understand, let's say a database system. As I mentioned, we are reading the data from database system, transform the data, and load the data into data warehouse system. Workflows, on the other hand, are much more advanced or capable than the data pipeline. Here we uh, can handle multiple different steps or different tasks one after another. So if you want to perform multiple tasks and those tasks have dependencies on the previous task, so in such cases you can implement workflows where right from scratch you can decide a flow, what should be the flow of data processing, and you can schedule that execution at a desired time. So you want to run that workflow at any desired time of the day or every hour, you want to execute that, you can schedule it for execution. Then when it runs, it will process some data operations. In the background, you will keep on monitoring the workflow execution, and it can also send a notification to trigger the another tasks. That can also happen. So these are the capabilities of workflow. And orchestration is again, it's a process of scheduling our data pipelines or workflows for the execution. Which day of the week or which day of the month, or at what time of the day, basically these workflows or pipelines will be scheduled for the execution. Managing the dependencies. There might be some sequential dependencies, or there might be some conditional dependencies, like three tasks are running in parallel, and if all the tasks are submitted, then all the tasks are completed, then next task executes. Or else, out of these three, if any task executes, the fourth task will start executing. Like this kind of conditional scenarios also we can set up, and we can monitor the pipeline execution with readily available, good-looking user interface on the available tools for the orchestration. Then there will be different mechanisms to handle the failures. So, for example, when we run the workflow, not always it will be executing. That's why sometimes this might fail. That workflow execution might fail. So, in that case, what should be the strategy? How we can correct the execution? How we can retry or restart the execution, resume the execution. So, for all such things on the orchestration tools, we get some readily available functionality, and triggering alerts or notifications to keep the owners of that workflow updated. What's the status of the execution, and whether all the tasks succeeded successfully or some tasks failed. About that, we can share the notifications on the Teams or maybe on the emails or through messages. We can configure such notification system also. So this is particularly the orchestration process. Yeah. Can you go to the next slide?
So before going to the next slide, Dhyanesh, I want to just talk to the people, like you have to stay till the end so that you can get the participation certificate, and also we have some special offer for you at the end. So yeah, now continue.
Yeah, sure. Yeah, guys. Hope it's going good and you are able to understand the things which I'm trying to convey. Meanwhile, if you have any questions, please feel free to interact. Okay, you can interrupt me, you can ask your doubts, and we can really make it more interactive. If you want to put your questions in the chat, please do that as well. I hope as of now I don't have any question in the chat. Okay, yeah, good. So as I was talking about processing the data or doing some implementing some pipeline, typically what stages data moves, what different steps we implement for data processing, and from which different steps it moves. Let's try to understand that. First is a data ingestion. First step, the very first step is data ingestion, which is a process of reading the data from sources. Now, what can be the different data sources? It can be any database systems or any APIs. It can be even different file systems, CSV files, Excel or Parquet files. It can be any JSON file formats where we need to read the data. It can be some logs or some streaming platforms like a Kafka, from which we need to read the data. So this is the very first step, extracting the data from the sources. Step number two is data storage. Once we extract the data, we need to store that data somewhere. So that is also called as a landing area where we store the data. Why we do this? Because as we discussed, the transactional systems, right? They are busy in providing the services to the clients of the business, the customers of the business. Uh, we should not run any complicated processes on the transactional servers because the performance really matters there. And whatever the internal processes we are running for our business purpose, they should be hidden from that customer's infrastructure. So on that infrastructure, we simply run the extraction process. But once that data is extracted, it will be stored somewhere to process it comfortably for the further purposes. And it can be any data lake or a delta lake systems. Now we talked about warehouse, but we have some limitations about the data warehouse. I'll not go much in detail today because this is not a very detailed lecture, I will say, about the data warehouse and all. But as of now, I'll just keep it at a very raw level, where I'll say if we have some drawbacks or some limitations. I'll not say drawbacks exactly, but limitations of the data warehouse system. For the storage of the data, then data lakes and delta lake kind of systems will come handy, and they will help us to store the data. So wherever we have limitations, data lake will help us to manage data efficiently. For example, data warehouses will store only structured data, where data lakes can help us to store any format of the data, let it be structured, unstructured, or semi-structured data. And on top of that, the data lakes are built. So these advanced systems will help us to keep our data storage efficiently so that we can further read the data from those sources and perform some further operations like the transformation, which is the third step. Now, transformation is a process of cleaning the data. As we get the data from sources, it can be data generated through some APIs. It can be data generated through some uh, sensors or user inputs, right? There might be some mistakes. So how we can correct that data? Maybe filling up the missing values, correcting the data values. And the three major transformation operations we see across the pipelines, they are filter, join, and aggregate. Filter is not always all the data is required for the analytical needs. So how we can cut down the data? Different types of filters we can apply on the data to keep only necessary details. Then join is about combining the data from different sources, as there can be different data sources from which we gather the data in the data ingestion. So that's the data ingestion phase, right? So those different data points we need to combine, and sometimes aggregation. For the analytics, we don't need transaction level data, so we aggregate it at appropriate level, appropriate hierarchy, and then we just uh, sorry we aggregate the data at appropriate hierarchy, and then we send it to a process. Integration after transformation, we go for the integration. Integration is basically the process of combining the data. Then analytics is getting meaningful insights. There are different types of analytics we run, and those with the help of analytical processes, we get some meaningful facts out of that data. What strategies we can implement for our business, for the growth, such kind of things we try to extract, and to present it to the management. We cannot put the numbers. They are not interested in the numbers. They need to know good looking graphs and charts. So for that, we have visualizations. So like this, it's a end-to-end process we implement in the data engineering life cycle. Okay, can we go to the next slide? To implement these processes, which technology stack we use? So for different processes, what are the different tools available in the market or technologies available in the market? You can see the list on the screen now. So for data ingestion, Apache Kafka, REST APIs, or the languages like SQL and Python will be useful. For storing the data, we don't store the data on the local machines, so we leverage some cloud capabilities. For example, to store any structured and unstructured data, AWS provides the S3 service. Similarly, Azure provides the data lake service. Then we have SDFS, which is one of the component of Hadoop ecosystem, relational databases, NoSQL databases, as well as some other file formats also we use. For data processing, we have distributed data processing engine, which is Apache Spark, which is the 100x faster again than the Apache Hadoop. So that Apache Spark, Databricks system, Python and SQL like programming languages again helps us to process the data. Orchestration and workflows, as we were talking about those terminologies. So when we want to design the workflow or orchestrate the process, multiple processes execution, then Apache Airflow, Databricks and Snowflake kind of platforms will help us to do that. For data modeling and transformation operations, DBT kind of tools are available in the market. They will help us to implement the transformations. And for analytics and visualization, Power BI and Tableau are typically the visualization tools, leaders of the segment. Okay, so these are the tech stacks typically people use for performing those operations in their daily responsibilities. Can we go to the next slide? Okay. As a last part of my discussion, I want to share quick few examples with you, like what are the real-time pipelines. Is there like some examples of the real-time pipelines? For example, the first example is Netflix. We almost everyone use Netflix, but how they are processing the data, how their pipeline works. So for data, the very first step is a data generation. How data is being generated for the Netflix, the internal purpose. Whatever actions we do on a Netflix screen, we may scroll through different contents or play different movies or web series, pause them, or browse for different contents, search for different contents on their platform. All these actions will create some information in the background, and that will be recorded. On the other hand, device telemetry or application logs, all these things will help Netflix to keep on generating the data, and that data will be sent to Apache Kafka clusters. So data ingestion is a process where we put that data, extract this data from the user application and feed it to the Apache Kafka server. So that Kafka server supports the streaming application. Streaming application means the continuous data processing, right? So as the user are using the applications, and billions of users are using the applications through continuously all over the globe, these events will be captured and will be recorded on the Apache Kafka. From there, Netflix can process that data on a regulated way. How they process. For stream processing, again, Apache Flink or Spark streaming is there. I was talking about Apache Spark. So Apache Spark has a stream processing capability. So any processing framework like a Spark, they can process the streaming and they can perform real-time aggregations and transformations on that data. And then they can push the data, store the data on the S3 or our ADLS, Azure Data Lake Storage. Then further, their analytics and ML system fetches the data from there and provides a real-time analytics. For example, the recommendation system, uh, alpha beta experimentation they want to do on that data, or quality monitoring dashboards, which are there. Like they want to have some visualization of their data, how where exactly the applications are being used, what kind of contents are being preferred more in XYZ regions. So such kind of analytics they will have readily available with them. Okay, so this is one example. Can you go to the next example, which is about Amazon e-commerce business? Yeah. So Amazon is again one of the biggest e-commerce chain, right? So how that system helps them to get the data generated and do some analytics on top of that. When we use the Amazon application, again, we might write some reviews on the products. We might do some purchases, or we might just keep on adding some products in the cart, or we just typically search for the products. All these user activities, again, in the background, they are creating the data. Then such data will be ingested using the real-time streaming events, and Amazon processes that using high configuration servers. They keep on processing the real-time data and aggregate over the customer behavior. They might have different clusters, like based on the products customers are purchasing, they have some clusters created. Clusters are basically the group of people who are interested in the common products. Their buying patterns are same, and depending on that they build a recommendation algorithm, like which user may purchase, like which particular product we can recommend to XYZ category of the people. So like that their algorithms are running in the background. There
Danish, are you there? I think you're not audible. Just a second, guys. I think there is some issue, network issue with Danish. So in the meantime, Dhyanesh is joining. You guys can what you can do is just ask your questions in the chat if you have anything to ask about either the data engineering or anything as per the Tailor Take or anything you want to ask. You can just write in the chat.
Hey, sorry guys. Somehow I just logged out. I don't know. So I think I'll just take a couple of more minutes to discuss, and I'll just hand it over back to Naitik for further discussion. So I was talking about e-commerce business of Amazon, how they capture the details as per the user behavior on the application and keep on processing those details for their business benefits. So after processing the data through streaming pipelines, they keep on storing the data on the data warehouse and data lakes. And after running some analytics on top of that, they might get some outcomes like customers also bought. We get to see that on their platform when we select any particular product. We get to see the related product they recommend, right? So how they do that? Because from the past history, which users has bought XYZ products together, their algorithms are able to capture such things, and due to that, they are able to recommend such kind of uh, feedbacks to the customer. And then a personalized homepage as per our search history, as per our interest of the products or previous purchase history. They might customize the homepage for everyone, which products should be visible on their homepage, and marketing recommendations as per our historical purchases, which could be the next products which they can recommend to us for doing all such things through which they can increase the sales. These people are very intelligently using the data which is being generated through their or through day-to-day basis users operations. Okay, next slide, please. The next example is about Uber. Okay, Uber business. So a lot of people across the globe again, they're using Uber for managing or planning their travel. So Uber is the largest travel company in the world which doesn't own any cab. That's a very interesting fact again. So what they are doing, they're simply having the data ecosystem with them. They have the driver application and they have the user or a traveler application. And using those applications, they just do matching of riders and the drivers. So both of their applications use the map APIs, maybe the Google Map APIs. If any user puts a cab booking request in that locality, what are the nearby drivers? All those drivers will get the notifications, and those drivers who are accepting the invite, that driver and rider gets connected for a ride, right? So that's one of the use case. On top of that, next is dynamic pricing. They keep on analyzing the different data points again. As I mentioned, they have access to map API. So on based on the road conditions, based on the traffic conditions, how they can increase or decrease the price dynamically. That algorithm works. Then trip analytics. For every trip, how much time it took, what was the user rating, and what kind of cabs are being preferred for different types of trips. So they keep on analyzing that data. And ETA prediction also, when we typically uh, start our trip, what's a expected time of arrival, or what time we are going to reach to our target, right, or a destination. So all such kind of things they predict in the background with their data processing, and help user to or improves the user experience. So such kind of systems help uh, users to use their system effectively. Can we go to the next slide? And I think the last slide for me to discuss. Yeah. Okay. So all these facts we talked. It was just a 1,000 feet view for all of you about the data engineering processes and tools. Now, what can be the career roadmap? How anyone can build career in the data engineering? The first step is to acquire the knowledge about foundation technologies. When we start, even if we have the generative AI to help, even if we have readily available tools in the market to implement our data engineering processes. But the very important part which we need to know is some programming skill. So we need to know the languages like Python and SQL, preferably. So whatever the syntax is, we are going to, like, whatever the codes even we get through generative AI platforms, we should be able to understand that, or we should be able to write some functionality right from scratch. So different data storage platforms to store the data of different formats, we should have the knowledge about it. Then the next phase is to learn advanced tools or platforms. Once we know the foundations technologies like languages and storages, then there are different data processing frameworks, or the cloud computing services, ETL pipeline and orchestration tools, which will help to implement end-to-end end-to-end uh, data engineering processes. So that way we need to know these tools. Next is to understand end-to-end data engineering processes. To understand that, we need to build some projects, right from data ingestion to transformation to store the data at appropriate location using the available tools in the market like Apache Spark or Databricks, or let's say Airflow, how we can orchestrate these processes. Such kind of experience you need to have by working on some real projects. And once you have that experience, we need to build the profile. We need to have good representation of our work, like a good resume prepared, LinkedIn profile where we can focus all our tech stack, and the GitHub repo of existing projects which we have implemented, which makes your profile stronger. And towards the end, we should have some framework through which we prepare for the interviews, by attending some mock interviews, which will help us to be confident about the work which we already did or the technology which we already learned, and crack the interviews for grab the job opportunities available in the market. So this can be the flow for the preparation for your career. Okay, so with this, I think I'll take a pause now and I'll hand it over to Naitik for further discussion.
Okay. So yeah, thank you so much, Daneshwar, for this really insightful session. I think people really know now what is data engineering and everything. So let's move to the next part of our masterclass. So once we understand what data engineering is and how system work in companies, so the next question is how someone can actually prepare for these things, this data engineering roles. So becoming interview ready usually requires more than just watching tutorials or learning tools individually. It requires a structural path that with both understanding and the practical experience. So understanding the field is the first step, and building the right skills to crack interviews is the next. So, this is the situation many learners face today. Why many learners struggles to break into data engineering. Learning from scattered tutorials online, no structured roadmap to follow, understanding tools but not building real systems, limited hands-on project experience, not knowing what companies expect in the interviews. So this is a situation with so many resources available online. People start learning from different places, but learning often becomes scattered and it's all unstructured. So as a result, they may know some tools or concepts, but they don't land up in any interviews, or maybe they don't perform well in the interviews. Uh, so yeah, this is the thing which many learners face struggle with. So, what actually someone's want to become job ready is a structured approach where learning should be done progress step by step. So, learning fundamental step by step, understanding how real data systems work, building complete data pipelines, working with industry tools, and practice interview scenarios. This is the most important part which to get you to become job ready. So instead of just learning individual tools, it's become very important to understand how the entire data system works and to gain hands-on experience building real data pipeline. So when learners combine strong fundamentals, practical projects, interview preparations, they become much more confident when applying the data engineering roles. So yeah, this is the key by which we can become a job ready. So the next part, which is the main part we wanted to talk to you about is the TailorTech Data Engineering Master Program. Crack interviews, get hired. So we have a structured 12-week program designed to help you become interview ready and job ready for the data engineering roles. So as you can see on the screen, three modules are there: data foundations, data pipeline and big data, cloud data engineering and projects. So SQL fundamentals, Python for data processing, Linux, Git basics, data warehousing concepts, and ETL fundamentals are part of module one. Then module two is Apache Spark, Databricks, working orchestration with Airflow, Kafka basics, modern data tech tools, which will comprise of module two. And the module three will be cloud data platforms, end-to-end data pipelines, capstone projects, pipeline monitoring, and interview preparations. So to support the learners in following this structured path, so TailorTech has designed this data engineering master program. So the program which begins with strong fundamentals and then and gradually moves to building data pipelines and working in modern big data tools in the industry. So finally, learners work on complete end-to-end projects and receive guidelines for preparing for data engineering interviews. So the main goal of TailorTech data engineering program is to help learners move from understanding the concept, actually building systems and becoming interview ready. So as you can see on this slide, shows just an overview of the program. So if you people are interested, we can share the complete detailed curriculum with you separately if any participants is interested in that part. So we are moving to the final part of our sessions, as you can see on the screen. This is a QR code. So if you are interested in exploring TailorTech Data Engineering Master Program, you can simply scan the QR code on the screen and send us a message on WhatsApp. So we will share the complete curriculum, upcoming batches details, and the program information with you. And the main thing which I want to tell you, this is for the next 24 hours master. So all the participants of the master classes participants will receive an special enrollment benefit here. This is for next 24 hours. So this is a benefit you will be getting. If you are interested in exploring the TailorTech Data Engineering Master Program, simply scan this QR code and send a message on WhatsApp and get complete program curriculum and upcoming patches details. So meanwhile, people are scanning the codes and everything, asking questions. We can just go few minutes, and if someone has any question, you can write on the chat, or you can just unmute yourself and ask.
Hi, Nantik. My name is Nitish. Thanks for the insights. So my question is, if you are giving us the training regarding the data engineer, so what the cloud it could be like AWS, GCP, or Microsoft Azure?
So in this program, what first I want to tell you that Dhyaneshwar will be the trainer out there. So he will be teaching out there. So I think Dhyaneshwar, can you please take up this question?
Yeah, sure, Nitik. Hey, hi, Nitish. So just to answer your question, primarily we'll be using AWS. Whatever the services we want to use from cloud, we will stick to AWS initially. But along with that, I will also let you know what are the equivalent services across the another clouds. For example, if we have S3 for storage on Amazon, how we do that with the help of Azure Cloud. which is an equivalent service. So such kind of comparative study we will do for other clouds also, but majorly for implementing our processes, we will stick to AWS.
So I think that gets your answer. What's your name? Sorry, one who asked the question.
So my name is Nitish Naitik, and as I have one more question, so I don't know you guys aware about the job market in US. So can you please give me the insights like what are the trending cloud that's going on in US? I mean, if you are aware about the market in US.
Okay, let me
Sure.
take this question up. I think in US market, as we see nowadays, AWS and Azure are mostly on trend. A lot of people are moving to AWS. There is so many things going on with Oracle as well, but they are like in initial phase. They are investing a lot on the multi-cloud side. If you can see the news and everything, Oracle is more toward multi-cloud, using multiple clouds together. So that is what they are more investing on. But nowadays lot of companies are using AWS, so many moving towards the Azure as well. So in this course also we'll try to go as deeper as possible in AWS, because we cannot cover each and every cloud. We might have a new classes or new batches for other cloud as well, but we'll make sure that you will get enough detail about other cloud as well, like Azure, GCP, even Oracle as well. Let's suppose we are teaching anything on AWS Glue or S3. So we'll try to compare those things with the other tools and program which is provided by other cloud as well. Like let's suppose we are doing S3 for this and blob storage for Azure. So this is how we'll try to compare. So we'll make sure that after this course you will have a deep understanding about Azure, AWS, but then you will have enough details about Azure as well. So this is what we're currently focused on.
Okay, yeah, thank you, Natik. Thank you for the answers. And yeah, and may I know how long is the course duration?
So the course duration is 120 hours.
120 hours. So it
Yeah.
could be like every weekday and the weekend too.
So it will be on weekdays. So basically 5 days a week. 2 2 hour daily session will be there.
Got it. Thank you.
Yeah.
There is one question in chat, Sukesh. Thanks for the question. But before answering the question, I want to know exactly in this 2 years time, which technology stack you worked as a data engineer. If you can,
So
okay. Okay, AWS, Python, Spark, Snowflake, awesome. Yeah, good to see that you already worked on some of the technologies of data engineering, right? But what happens, typically when we work on a project, we typically stick to the technology stack which are related for our project, and we miss on some other alternatives or some other technology stacks which are still available in the market. As you already said, Snowflake, you already use Snowflake, but on the other hand, the competitor to the Snowflake is a Databricks. That organization, that platform is actually growing like anything. And like this course will help you to get some additional skills on your profile, which will open up multiple opportunities in the market. Like, it's good that you have some hands-on experience on the projects and some tools, but along with that, if you have some other tools added on your profile, then it may open lot of opportunities for you for your career growth. I think that's my perspective. Maybe Naitik, Umang, if you want to add anything.
no, I think it's enough. Like what you said. Any other questions or anything, or any doubts which you want to ask about regarding data engineering or about the trainer? or anything specific about TailorTech or anything? In the meantime, people can the code which is given here, and people are, I think, are responding to the, and I'm getting a lot of messages here. So this is just a I'm just to let you know, this is just a 24 hours special offer which we are giving here. So please grab that offer if you want to if you are interested in joining our course. So I think if there are no questions, we are good to go. Then Dhyanesh, you want to say something or anything at the end?
Not much, but just want to convey one message from my end. I think so. I don't know the exact background of you people, but even if you are working in the data engineering or maybe some other domain of computer science, I think this is a field which will grow further because it's all about data and so if it's always good to know the different technology stack and different processes which people implement in this area because as we see the generative AI at a rate of at which that domain is increasing, I don't think coding jobs are going to be there in the market for upcoming future. So this is where we need to know about data processes where we can still be ahead of time. Thank you guys. Thank you so much. Over to
So
you all.
yeah, I think we have just done with the session. So once again, thank you everyone for joining today's TerraTech Data Engineering Masterclass. So hope these sessions have helped you regarding the information what you get regarding the data engineering and how the data pipelines works in real life systems and what are the skills required for this field. So, if you're interested in exploring this TailorTech Data Engineering Masterclass of us, so you can just simply scan the QR code as we say, or you can just message us on the WhatsApp number which is given here. So we will share you the whole curriculum, best details, and everything out there. And it's okay, like if you're not interested or any doubts, you can if you also have some doubts, you can just ask us or text us at the WhatsApp messages regarding anything. About any other boot camp or regarding any other course or anything, so you can just text us at this number. And as I mentioned earlier, for the participants, so the masterclass 24 hours, for the next 24 hours we will have a special offer. You can go through this, and thank you so much once again for your time today. We will wish you all the best for the data engineering or whatever future journey you will have having, and have a wonderful day. Thank you.